Good morning, everyone. I hope you guys are doing well. I think your grades were not bad. Most of you, I think all of you took your exam. If you have any questions about the exam, you can ask me general questions now. Just unmute yourself and ask me. If you want me to help you with a problem, email me very specifically. Tell me your course number. This is Trig 1112, and send me a link to the problem. I will be happy to incorporate that in the next lecture. A couple of little things that are important, but kind of not, I shouldn't say not too significant, but they are significant, but they're not about math. So I'm going to go over it, okay? So on the left-hand side, you see where I announce things, okay? I try to be as clear as possible. Today's lecture, the one that's being recorded now, will show up here. You guys know. Now it's on top. Recorded lectures are on top. And then class link, this is the link you use to join me. And now it says study guide for exam two. We just took exam one. Don't worry about these sections, okay? I will adjust them. If I don't do 3.2, you won't be responsible for 3.2. So don't panic and start emailing me that we didn't do 3.2. Will it be on exam two? Your exam two will be on July 3rd, okay? It's all cumulative. So keep that in mind. You want to make sure the ones you messed up on exam one, you take care of them. Some of those problems will show up again. Um, so those are the sections tentatively I'm going to cover. I don't know. Okay. How many lectures do I have? We have exactly 6 lectures before exam two. That's not a lot, but I am thinking we should be able to cover up to 3.2. So just be aware of that. Again, don't let this bother you. And here is office hours link right here, Monday and Wednesday. If you want to meet with me any other time, I am free. I'm on the East Coast of the US, and most of you are there too. I am free from roughly, in the morning I teach. So from noon till 8 p.m., I can meet with you. How do you schedule an appointment? You email me saying I can't come at that time, at that hour during your office hour. I would like to schedule an appointment tomorrow at 7 o'clock. I will tell you, yeah, 7 o'clock works. So I will tell you, hey, I can meet with you at 7 o'clock. Can I meet with you at 8 or 5, something like that? Okay. You can also give me more options, multiple options, and I can pick one, your choice. I'll probably use the same link. I'll say come to the office hour link. Okay. So you would know where to go. So this is just a little bit of uh, talking about the environment of Blazeview. Another thing, you should be able to see the problems you messed up, okay, on exam one. Some of you asked me how to do it. Once the exam time slot, I give you 24 hours to take the exam. It was a little more than 24 hours. Don't worry about it. Yesterday was a holiday. I didn't expect you to work on it, but I turned it on. So anyway, when the exam was over yesterday at midnight, I think. So so after that, most of you know you have access to the exam. You can see your answers where you messed up. Make sure you fix them and you don't mess up the same problems again. Any questions about some of the things I talked about? And I will tell you in a minute what we're doing today. Any questions, guys? All right, guys. So the plan today is to start 2.3. Okay. 2.3 is an interesting chapter. I'm going to talk about a couple of concepts that you will see again, okay, later, and you will have a better understanding later, okay? I will go over it even though these topics, the 3 topics that I will talk about, will not show up in the problems. So if you find it a little vague, it's okay. And it won't be vague when we draw graphs. It'll make a lot more sense. Now, in this section, we're not going to do graphs. And I personally believe that I honestly don't understand why they're talking about some of those things in this section, but they are, and we will cover it. The good news is these ideas will not be assessed in the exercises or problems, but might as well talk about it a little bit. I'm sure there is some reason why they want us to know that, okay? And they will come back again. When they come back again, things will hopefully make a lot more sense. So I'll show you the calendar, guys. This is June. I'm just um, shouldn't say distracting, and it's more like a detour. So we only have a class today. Sorry, today is the 21st. 1, 2, 3, 4, 5, 6. After 6 classes, we have our exam too. Okay, just to remind you, back to our 2.3. We're going to talk about a couple of concepts. These are very important ideas, but they really belong to one of the future sections, okay? But they're here. We're going to talk about a little bit. Actually, I kind of see why they're talking about it because those words will come up here. So now in 2.2, guys, we define this is a unit circle. This is a unit circle. And we define sine and cosine. Sine as the y coordinate and cosine as the x-coordinate. And we also said since this circle is a unit circle, if this length is t, and this is 1, sine theta, theta will be same as t. Remember that arc length formula? I'm going to go over it. It's a little bit of a review. We did say that s, the arc length, is equal to r theta. And let's make it a little bigger. Let's make it a little bigger. And r is 1. So if you replace r with 1, s is theta. But s, we're calling it t, the length of the rope. I'm just not going to write 1 theta is 1. And instead of s, I'm going to write t. So whatever this length is, this theta is going to be the same. We discussed it, but here it is again. Okay, so don't panic when we write it that way. They're going to be the same because we are talking about unit circle. Okay. Again, I'm reviewing a few things from 2.2. And I'm just going to double check that I'm being recorded. Okay. I think recording is working fine. All right. So now we did say this rope can wrap twice, 3 times. And if it wraps up counterclockwise, we say the number is positive, the angle theta is positive, the length of the rope is positive. If you go counterclockwise, if you go from here like this, same thing, it can wrap up multiple times, as many times as you would like, and the theta value will be negative. So what if I ask you, what could be the set of all possible values of theta? You would say all real numbers. It could be anything. It could be anything from 0 to positive infinity. And a set of all real numbers, we write it like this. You can, of course, say a set of all real numbers. Set of all real numbers. Now, okay, they won't let me write it like this. That's okay. We're going to use a different box. Set of all real numbers. Now, set of all real numbers are numbers like 1, 2, 3, -1, -2, -3, 3.5, 4.5, square root of 2, 7.5, square root of 7.5. Actually, pretty much any number you can imagine, positive or negative, are real numbers. Now, theta could be anything, okay? The value of theta could be anything, and positive or negative. You can also write it like this. If you don't want to write it like this, you can also write it like this. Now, I'll see if it allows me to, no, it won't. Okay. Anyway, I have to handwrite it. Okay, guys. Um, I have to handwrite it. Negative infinity to positive infinity. And these are called open parentheses. Okay. They're not square brackets. Okay. You can write it like this or like this. Okay. So that's that. And this fancy word, guys, all possible values of theta is called the domain of the function. Okay. It's called the domain of the function. Domain. It's called the domain. This is what we are talking about are called trig functions. So I'm just going to say this is called the domain. Now, when you put in theta, just look at cosine theta. Cosine theta, and let's just talk about sine theta. Cosine theta and sine theta. Okay. Now, the domain is all real numbers. I'm going to write it like here for both. All real numbers. All right. There's one more term associated with trig functions called range. So guys, when you replace theta with any real number of your choice, 2, 2 pi, 3 pi, doesn't matter, you get a value for the x and y coordinate. Now, the x and y coordinates are on the unit circle. So the maximum value they can attain is a 1. They will never be above 1. They can be below 1. They can be 0. So the range for cosine and sine, actually both, it's called range. When you input theta, what is your output? The input values are called domain, and the output values are called range. What is the range? Range. All real numbers between 1 and -1, including the endpoints, including 1 and -1. I'm going to write it here, including -1 and 1. And you really want to understand it. Don't worry about the word range too much. What we are saying, sine value and cosine value will never be more than 1 or less than -1. If you want to write it like this, you can. You can also write it like this. It's the same thing. Square bracket, -1, comma 1, comma 1, square bracket close. Okay, these brackets have to be square brackets. And I'm going to go back and write your domain as follows. I knew how to write infinity here, but I'm not going to fiddle with it. There's a shortcut, which I kind of forgot. It's here. All right. So again, you do want to understand the sine value and cosine value will always be between -1 and 1, and 1 and -1 are included. When your rope ends here, the sine value is going to be 1. When your rope ends here, the cosine value is going to be the x coordinate, which is going to be -1. When your rope ends here, the cosine value will be 0 and the sine value will be -1. So it'll never be above 1. If you somehow get an answer for sine theta more than 1, you know you're wrong. Or cosine theta less than -1, you know you're wrong. So here are two fancy terms for you, domain and range of trig functions. And they will be, this is more like input. Let me write it down. Input, what can you input? And this is more like output, what comes out. Okay, range is the output values, what could be the possible output, and what could be the input. All right, now you're going to learn a lot more about these two ideas in chapter 3, so don't worry way too much. Okay, any questions on input, output? Input, output are informal terms. I'm going to say domain and range, guys. Any questions about domain and range? All right. You can always unmute yourself and ask your questions. Okay, this slide is from your book. I don't even have to take it there because it's something you already know. Sine theta is y, cosine theta is x, cosecant is reciprocal of sine, secant is reciprocal of x cannot be 0, and here y cannot be 0. And tangent is sine over cosine, y over x, cotangent is flipped. So nothing too fancy, you already know it. Domain, we have talked about it. I'm not going to worry about domain of tangent functions. If it comes back, we'll discuss it. Don't worry too much. So here's a nice table. You just need to know the first two, and I've discussed sine and cosine, domain and range. They are here, and don't worry about don't worry about the rest of them too much. All right, guys. So here's this one we need to discuss. You really want to understand it, okay? Let me bring that picture here. So when we say periodic, what does it mean? Function f, we are talking about trig functions. Let me see. That's not bad. We can make it a little bigger for you guys. The function is periodic if there is a positive number p such that theta in the domain. So it seems very fancy, okay? So sine and cosine functions are periodic. Tangent, secant, cosecant, cotangent are periodic too. And it's all they are saying is this. So when your rope goes here, and then take a bigger rope, let's say, if it comes back here again, they're going to be the same. So if the rope goes around one full circle and then come back, stops there, the x and y values are going to be the same. So for different angles, you get the same value. So let's say, I'll give you an example, guys. Let's say, just because I have this picture, this angle, let's say is 90, 110. I'm just guessing, okay? 110. Doesn't have to be accurate, really doesn't matter. Let's say theta is 110 degrees. Okay. Now, if you add 360 to theta, 360 plus 110 is, I think, 470. Let me double check. I think that's 470. Now take a look, guys. If this is 110, this stopped here. The x and y values are simply sine and cosine. Everything else, secant, cosecant, tangent, cotangent, are going to be the same. Why? Look, if you go 470, 470, that means you're going full 360 plus 110 here. So you're going to land right here. So the sine and cosine values are going to be the same for 110 and 470. So let's write it down. And that's what they mean by periodic. So sine, I'm just going to give you one example. Sine 110 degree is equal to sine 470 degree. And if you add 360 twice, I do need my calculator for that. I don't want to mess it up. It's going to be still the same, sorry. It's going to be still the same. And you really want to get that, okay? 110 plus 360 is 470. 110 plus 2 times 360, you make the circle twice, is 830. That's still going to be the same. 830. So what's going on here, guys? All we are trying to say, adding 360 degree for sine and cosine doesn't change the value. And we say the period for sine and cosine is 360. Let's write it down nicely. It's called the period. After 360, it's kind of like a cycle, okay? Period is like a cycle. Right? Sine, let's spell it correctly. Sine and cosine is 360. Or what does that mean? After 360 degrees, it repeats. They repeat. Okay. Now, We are going to discuss this on the next slide, but since we are here, let's discuss, by the way, if the period for sine and cosine is 360, the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. Periods for those two are going to be the same. Sine, cosecant, and secant is going to be the same. Now, interestingly enough, guys, tangent is different. Okay, I'm going to write down and then I'm going to explain it pictorially why the period for tangent and cotangent is 180 degrees. I don't need this slide anymore, so be a little patient. It's a little challenging what we're going to discuss now. Okay, I don't think I need this. So let's write it here. Let's write it here. And we're going to claim, and I'm going to explain to you why that is the case. The period for, we're going to first prove it for tan, and cotangent is going to be the same because it's the reciprocal. It's not 360. It does repeat after 360, but when we talk about period, we talk about the smallest cycle after which it repeats. It's actually 180. Okay, why is it the case? Oh, guys, I'll give you one example. Let me grab a better unit circle. Okay, I don't need this. Give me 1 second. Okay, so this is a unit circle. Okay, now take a point here, and I'm going to make it up. Okay, let me see what I can make up. Well, let's just call it X and Y. Okay, this point. I'm going to call it X comma Y. X is positive and Y is positive. Why? Because it is in the first quadrant, right? Now, X is the sine value, X coordinate is the sine value, Y coordinate is the, X is the cosine value, I'm sorry, X coordinate is the cosine value, Y coordinate is the sine value. Now, what happens, guys, if you take this line and move it exactly 180 degrees, it's going to fall somewhere here. It's going to fall somewhere here. Okay, and let's call that point the coordinates of this point will be, if this is here, if this is X, let me do a drawing. If this is X, this is going to be negative X. I'm going to delete the pink drawing. Look at this handwritten. If this is Y, this is going to be negative Y. Now take a look. Tangent is sine over cosine. So the tangent for this point, I'm going to write it nicely. I'm going to say tan theta is X over Y. That's how it's defined. And for this, if this is theta, this is going to be 180 plus theta. Now remember, guys, 180 is pi. We're going to write pi over theta. Pi plus theta, not over. So shouldn't this be negative X, this coordinate is going to be negative X and negative Y. So what's negative F? X over negative Y, same as X over Y. It's really what I'm giving you guys is a formal proof, really. And you can do the same thing with cosine, because cosine is Y over X. It's going to behave exactly the same way. So this is an explanation why after 180 degrees, the tan values will repeat. So the period for tan and cotangent is 180 degrees. Okay, so some of the little slides I'm using from your text, you should keep them handy during your exam. Of course, if you remember them, that's the best. If you can't remember, write it down. The period for sine and cosine is 360 degrees. That means after 360 degrees, the values repeat. And the period for cosine and secant is also 360 degrees because they're reciprocal. They behave the same way in this area, in this context. But the period for tangent and cotangent is 180 degrees, and the explanation is right here on this slide. I'm going to pause it a little bit just to see if anybody has any questions for me. So this idea will come over and over again. Okay. Let's see what else is going on here. So guys, we just discussed this periodic properties. Instead of 360, they're writing 2 pi, same thing. Instead of 180 degrees, they're writing pi. Same thing. All right, this one is easy. Let's go over it. Let's go over it. This is a very easy concept. And I think we have discussed it in chapter 2.2. So I'm going to take a point here. Let's change the color to something a little more striking. Make it pink. Let's say this point is here in the first quadrant. All right. Both x and y are positive. That means sine and cosine are positive. That's what they're saying. Okay, in the second quadrant. And let's find if sine and cosine are positive, then cotangent and tangent will be positive too, because they're simply sine divided by cosine. And if sine and cosine are positive, cosecant and secant will be positive because reciprocals of a positive number is a positive number. Let's go here. So sine is positive, but cosine is negative. That's what they're saying. Sine is positive, sine's reciprocal cosecant is positive, cosine is negative, its coordinate is negative, and cosecant's reciprocal secant is negative. And tangent and cotangent is one divided by the other. If one is positive, one is negative, it's going to be negative. Okay? What happens in the third quadrant? This is the third quadrant. Both x and y are negative. And like before, you have sine and cosecant negative, cosine and secant negative, but tangent and cotangent are both positive because a negative number divided by a negative number is a positive number. Okay, let's try the next one and the last one. Here, let's say your terminal point is here, x is positive, y is negative. If x is positive, x is cosine, cosine is positive, secant is the reciprocal of cosine, that's also positive. Sine is negative, reciprocal of sine is cosecant, that's also negative. And you have those two negative. What about your tangent and cotangent? Tangent, cotangent is, they are simply one divided by the other. If one is positive, one is negative, they're going to be negative. So that's what this little box is about. All right? Not a difficult concept, not too difficult, but you can always unmute yourself and ask your question if you don't follow. This is repetition. We have discussed it. I'm not going to go over it again. Okay, this is important, guys. Okay. Now, let me bring this here. This is very important. Why don't I do one thing, guys? Anytime it will ask me to stop because it's almost 30 minutes since we started. Okay. It'll give me a warning. So let's come back real quick, real fast. We're not done. We have a part 2 of this class. So come back soon. All right. I'll be there.